Have you ever really stopped to think about what's happening in that split second when you turn the key in your car? I mean, we do it every single day without a thought, but it's actually this incredible, high-speed chain reaction of electrical and mechanical wizardry. So let's dive in and pull back the curtain on the journey from a simple key turn to that powerful engine roar.
So that's the big question, right? What is actually going on in that tiny gap between cause and effect? We're going to follow the spark, trace the power, and really uncover the hidden dance that brings a massive, heavy engine roaring to life.
Okay, so before we meet all the individual parts and pieces, let's just get straight on what the core mission is here. What is this whole system even designed to do? Well, at its heart, it has one single fundamental job: to give the engine that first big push it needs to get going.
And this is really the key thing to understand. An engine, for all its immense power, can't start itself from a dead stop. It's kind of like trying to ride a bike. You can't just sit on it and expect it to go. You need that first hard push on the pedals. The starting system is that push. Without it, your engine is just a really, really heavy and very useless piece of metal.
So who are the actors in this high-speed drama? Let's meet the cast. You should think of these components like a perfectly rehearsed team, where every single one has a very specific, absolutely vital role to play in a perfect sequence.
All right, here's our lineup. First up, you've got the battery. That's the powerhouse. Then the ignition switch. That's our trigger. Next, the starter solenoid, which is kind of like the brains and the brawn of the operation. That little guy activates the starter motor, the real muscle. And finally, all of that connects to the flywheel, the direct link to the engine itself. Together, these five perform this incredible electromechanical ballet. Okay, let's get to the main event and see how this all comes together. We're literally going to follow a single jolt of electricity from the second you turn that key, all the way on its mission to fire up the engine. So here it is, the whole play-by-play in 5 quick steps. It all kicks off with step 1, you turn the key. That simple little action sends a small electrical signal to step 2, which wakes up the solenoid. The solenoid then, in step 3, unleashes a massive flood of high current to the starter motor. This kicks off step 4, causing the motor to spin like crazy and its gear to shoot forward and engage. And that all leads to the grand finale, step 5, the engine cranks. Now let's zoom in on the real MVP of this whole sequence. We have got to talk about the absolute star of the show, the starter solenoid. This thing is truly the unsung hero of the entire system. It might be a small part, but it performs 2 completely different, yet simultaneous and totally essential tasks.
And you can see its split personality right here. On one hand, it's a super powerful electrical switch. It takes that tiny little signal from your key, we're talking less than 1 amp, and uses it to slam shut a massive circuit, opening the floodgates for a huge river of current. And at the exact same time, it does a mechanical job. It physically shoves a little gear, called the pinion gear, forward so it locks into the engine's big flywheel. And once those floodgates are open, wow, we are not talking about a trickle of electricity anymore. A massive flow, often hundreds of amps, rushes straight from the battery to the starter motor, waking it up from a dead stop with incredible force.
This is the moment of truth. All that electrical energy is now instantly converted into raw spinning force. The starter motor spins with unbelievable torque, and because its little gear is now locked in with the flywheel, it forces the entire heavy engine flywheel to turn. That cranking sound you hear? That's what this is. This small motor is literally turning over the entire massive engine.
And here's the handover. As the starter motor gets that crankshaft spinning, the engine's pistons start moving up and down. This allows the engine to finally begin its own 4-stroke cycle: intake, compression, power, and exhaust. As soon as that first spark of combustion happens, the engine starts making its own power and can finally run by itself. The starting system's job? It's done.
But wait, the story isn't quite over the second the engine roars to life. The moment you let go of that key, a final, absolutely critical act takes place. This part's all about a clean handoff and, more importantly, a safe getaway.
But before we get to that disconnect, it is worth just pausing for a second on the beautiful science at play here. This whole system is a perfect example of energy conversion. You're taking stored chemical energy from the battery, turning it into electrical energy, and then transforming that into the raw mechanical force that brings an engine to life. Just amazing.
Honestly, this is the perfect 1-sentence summary for the whole shebang. At the end of the day, it's all about that transformation, taking potential energy just sitting there in the battery and turning it into the raw motion needed to let the powerhouse of your vehicle finally take over. And that brings us to our final and pretty important thought. When you release the key, the circuit to the solenoid breaks. This instantly does two things. It cuts the power to the starter motor and it pulls that little pinion gear back. Now this disconnect is so critical. Just think about it for a second. What do you think would happen if that small starter motor stayed connected to an engine that's now spinning at thousands of RPMs? It would be destroyed in an instant. This final elegant step protects the entire system, making sure it's ready to do it all over again the next time you turn the key. It's an incredible piece of engineering we all rely on every single day.